All right, welcome to Friday, the last day of the week. Yesterday I went through most of example 1 and I posted the notes. And today I'm going to start lesson 2. Again, as I said at the beginning of this unit, this is a fairly short unit, especially compared with some of the other units that we did at the beginning of this course. So we have trimmed means, and then we're going to talk about a weighted mean, and we're going to talk about percentile, and then that's it. So we started lesson 1 talking about the mean, median, and mode. Today we're going to start talking about what a trimmed mean is. And you can see that probably when you were doing some of the questions in assignment 1, you might have noticed that some of the numbers in the group just didn't seem to belong. For example, just going to move this out of the way. These are all my notes from assignment 1. When we looked at number 3, and I think Cynthia, you had a question about number 3. If I look at number 3, there's a class of students, their marks are all pretty good, right? They're in the high 60s, 70s, 80s, except there's 2 students with marks of 0. Those marks don't seem to belong, right? It's almost as if maybe these 2 students weren't even in class when the instruction was going on. So if they're writing a test with no knowledge, that's not really a reflection of what the rest of the class is. So these kind of don't belong. This is where we might use a trimmed mean, right? And get rid of the marks that don't belong. But there's a process to it. Mr. Jimenez in number 2 as well, his wage of $5.50, that's an outlier. That one really doesn't belong. It shouldn't be in the group. So in cases like that, where there's one number that clearly doesn't appear to belong, we use a trimmed mean. But there are rules to using a trimmed mean. You can't just delete scores that you don't like. There's a process that you have to follow to make sure that your calculations are still valid. I'm just going to move this camera over before it falls off the. Okay, so lesson 2, a trimmed mean. And trim, like if you were going to trim your hair, you'd be cutting your hair, right? And that's exactly what we do to the data. We cut pieces of the data out, but again, we can't do this randomly. We have to do this. Hi, Tim. We have to do this. Hi, Cynthia. We have to do this with a process, right? So let's take a look at example 1. And nice enough, they use Mr. Jimenez and his factory workers again from the previous lesson. So that's kind of nice because that's the one I was just talking about. Recall Mr. Jimenez and his 19 factory employees from the last section. Their hourly wages in dollars were given. So there's 20 numbers here given to us, right? The 19 employees, and they're really big. So if I want to remove an outlier from the top end, I have to remove a number from the bottom end as well. That's how the trimmed means work. So it says, determine the trimmed mean of the data above. If you trim the top score and the bottom score, please note that the top means the highest and the bottom means the lowest. That's really important as well. Your data should be placed in order, right? Just like when we placed it in order, calculating the median. Remember to determine the highest value or the lowest value the data must be placed in order. Just like you ordered them for the median. Oh, I don't know, Tim. Cynthia, is your video cutting in and out as well? Tim says it's cutting in and out for him. We'll see if Cynthia's is. If Cynthia's is, then it's my feed. But if Cynthia's isn't, then I think it's your internet, Tim. I'm going to wait and see what Cynthia responds to me. Okay, I'll keep going. We'll wait for her to get back to us. All right, so when I look at the data, right, the data was given to me, And if I want to take out the top number, because this number clearly doesn't belong, I'll try talking slower too, Tim, so maybe if it cuts out, you don't lose as much. If I take off the top, I have to take off one of the bottoms, so one of the 11s disappears. And now it says calculate the trimmed mean. Okay, so let's see, how many 11s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 11s, so 12 times 11. I have 12 of those plus 1, 2, 3, 3 12s. So 3 times 12 gives me 3 12s, plus 2 13s, plus a 14, right? So I'm going to add all these up, and I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It should be 18, right? Because I cut out the top and the bottom. So let's see what we get here. I'm going to total my top first. I get 208 on the top and 18 on the bottom. So that gives me, you can see this, 11.56, I guess, if I rounded properly. $11.56 per hour. That's a much better hourly wage than the previous one of $38.54, right? This is far more representative. This is a better answer. So you can see why trimmed means are used. Okay, let's ask now we're going to answer this question as I was just talking about this. Do you think the trimmed mean is better or the regular mean? The trimmed mean of $11.56 per hour represents the data better than the regular mean, right? Than the mean of $38.45 per hour. Okay. Because the trimmed mean gets rid of that super high number. Right? So just get you a look at that. Okay, thanks, Cynthia. Cynthia said she had a disturbance, so she's no longer live. She has no idea now. There's someone else that was watching for a minute, and now they've popped off. Let me know if it improves at all, Tim. The internet is really great. Some days it's not. So I'm not really sure, Tim. If it's really bad, I'll check this later today. If the feed is very, very bad, then I won't do it live anymore, and I'll just record earlier in the day when the internet traffic might be a little slower, and then just post things. Okay, I'm going to move on to page 7, example 2. The following data shows Elsie's test results for the last 8 tests in her science class. These are all percents. So she got 87, 93, 88, etc., etc. 1, 2, 3, 4, 5, 6, 7, 8. Calculate her mean test mark. Okay, so all I have to do is add these numbers up. I'm just going to count again to make sure I have all of them added or all of them represented. 3, 4, 5, 6, 7, 8. Yeah, I'm going to put my brackets around to remind you that you have to subtotal that first. And I'm going to divide by 8 because there's 8 of them. Okay, and we're going to calculate Elsie's mean mark. And I get 584 on the top and 8 on the bottom And we get an average mark of 73. It said it was percent, so I'm going to record it as a percent. So 73%. Just auto-focusing. Now, calculate her trimmed mean if you trim the top and the bottom score. Okay, so the top is remember, it's the highest, and the bottom is the lowest. Okay, so which would be her lowest score? Well, obviously it's the 12%, right? That was a really bad mark. She might have had a bad day. And the highest score it looks like she got was the 93. So if you want to take off a low, you have to take off the high. So now we have to calculate her trimmed mean. So her trimmed mean will be 87 and 88 and 76 plus 65 plus 72 plus 91. I have to subtotal those. Now, if you trimmed off the top and the bottom score, the high and the low score, you're only going to have 6, right? 1, 2, 3, 4, 5, 6, 6 marks. So make sure you reflect your new number of data values. So let's see what we get this time. So we get 479 divided by 6. And that gives me a mean mark or mean average of 79.83. Which is actually higher than the other one, right? Now we have to make a decision. Which mean, the normal one or the trimmed one, do you think is a better indication of Elsie's test performance for this class? Justify your answer. This might be actually a hard question to answer unless you were Elsie or her teacher. But if I take a look at the marks, if I kind of take a look at this, 93 isn't really, like, that's not really a super high mark for her. That's kind of like a mark that would be, I don't know, normal for her. She has an 88, an 87, a 93, and a 91. So this 93 is not really out of character for her. This 12% is out of character, right? So by dropping this low score, it looks like this is the true outlier, and this is the one that really doesn't fit her ability. She might have had a really bad day, been really sick that day. She probably shouldn't have written the test that day. So I think for sure her teacher should have dropped that one, but if the teacher drops this one, they have to drop this one. So I think that her test score really, the higher score is more reflective of Elsie's work. This is quite a bit lower. It should be the higher score. So I think the trimmed mean is a better representation of her work. All of her other test scores were quite high. So I would use the trimmed mean because it's higher than the normal mean. Oops. Okay. All right, I'll let you think about that one. Now, in that previous example, the trimmed mean brought the wages of the factory down, and that was a better indicator, right? Because the wage that the owner had posted was too high. So sometimes the trimmed mean can make the mean higher, sometimes trimming the mean can make it lower. But you should decide which is the better representation of the data that you're studying. Okay. Let's take a look at example 3. Was there any questions? Your friend Denise was trying to calculate the trimmed mean of the following data. Her work is shown here. The problem is that her answer is 6 not match the answer key. What error did she make? Okay, she's trying to do the trimmed mean. Well, let's see. She just slashed these two because they were on the ends. The data wasn't put in order though, right? If she was doing a trimmed mean, she should have slashed the 17 and the 93, right? So let's redo that question. She should have put the data in order first, right? If she can't determine from the chart which is the high and the low, she's going to have to order it. So 17 is the lowest number, right? Then it would be the 67. Then it would be the 68. So I've done this one, these three, right? Then it's the 75, the 81, and the 93. So 6 pieces of data. 1, 2, 3, 4, 5, 6. Okay, if she's going to do a trimmed mean, you take the lowest off and the highest. So that leaves me with these numbers. So the trimmed mean, let's see if we get the correct answer this time, is going to equal 67 plus 68 plus 75 plus 81 divided by, okay, we only have 4 pieces of data now. Let's see if we get the right answer. Okay, 72 plus 75. Okay, all we know is that her answer was 63 and it was wrong, so let's hope this is the right answer. So this is the correct trimmed mean. So unless you can easily pick out which is the highest and the lowest, I mean, in this case, it wasn't that hard. There were only 6 pieces of data. Sometimes if there's a lot of pieces of data, though, you want to maybe order the data so you can clearly see which is the highest and lowest numbers. But that one wasn't that hard, okay? So the trimmed mean, it's kind of nice. This lesson isn't really learning a whole bunch of new things. It's just taking the one of the concepts from lesson 1, the mean, and then just utilizing that formula in a trimmed capacity. And trimming just means you either cut the top and the bottom out, the highest and lowest scores, I should say, or you could trim 2 pieces of data. If they wanted you to trim 2, that's fine, but you would trim the top 2 and then bottom 2, and you would just be left with these 2, right? You can trim as many pieces of data as you want, but you have to match the number you trim from the high scores to the number that you trim from the low scores. So just remember that. All right, let's turn the page. Tim, if you're still listening, how is the feed right now? Is it still cutting out all the time? All right, you can start working on assignment 2. I'll give you time to work on assignment 2. I'll stay on the line for a few minutes. And then I'm going to check the video quality. And then Monday will be a work class for practice assignment 2. I'm going to open a Google Meetup. I'll post the answers on the Google Meet as well, but then I'll have a Google Meet so you can hop on and ask me any questions that you have. Okay, so no one's asking me any questions. So I guess I'll sign off. Please email me if you have any questions though, right? And I'll check, I'm going to check the feed as well. If it's horrible, I'll re-record it. But we'll see. Okay, so have a nice weekend, everyone. Check in with me in email if you need me. You can get my email. You can just get me through email through the blog. If you click on course outline, my email address is there. You can just click the contact Kim form on my blog as well. That goes directly to my email. So any way you want to get a hold of me. Okay, talk to you later. Bye-bye.